everybody, and welcome to this video. In this video, we're having a look at intersections and unions in probability. So we go back to our Venn diagrams that we did last time. A union is when we are looking at the word or. So if we have two events and we are interested in A or B, we are interested in a union. And what we have in the diagram above is all of the colored regions that would be this A or B. So the part of A only, which is this part here, is part of A or B. A and B is part of A or B, and B only, which is that part there, is part of A or B. So A or B is what you get when you're looking at either of the cases. So if you wanted to know how many people drink milk or no milk in their coffee, or let's take another, those who drink tea or coffee, rather, then you would include the people who drink tea, the people who drink coffee, and the people who drink tea or coffee would all fall under that. For the intersection, we are looking at where both of the events are definitely happening. So for example, here we have, okay, so it's written A and B. So this is the symbol denoted, and this here we say and B. So we want to know where both events occur. So for example, if you want to know who drinks tea and coffee, you're only looking at the middle part where they overlap, because that is an intersection. So our union is A or B and denoted with this symbol, and our intersection is A and B and denoted with the symbol. Please take note of what each word or thing corresponds to. Now, we've got this identity that's quite popular in probability, and that it is A or B is equal to probability of A plus the probability of B minus the probability of A and B. I'm just going to show you how is this the case. So if you remember, the probability of A or B is when we color both of these circles with everything in between. So let's do that. I'm going to color the probability of A in yellow. So we have the probability of A. Excuse my coloring. So this is the probability of A. Probability of A is everything that is in A, plus the probability of B. So now let us color in the probability of B. So the probability of B is this over here. So what I've colored now in is B only. B only. But we're also including this part. So that's the whole of B we've included in this formula. But now what you see is that we've actually counted the middle part twice. Can you see? We've counted the middle part when we calculated the probability of A, and we calculated the middle part. So when we calculated the probability of A, then we colored the middle part A and B. And when we calculated the probability of B again, we colored the middle part of A and B. So what we've done essentially is double counted the center. So what we are doing then is subtracting one so that we are left with just everything colored in once. So we're just subtracting that one piece, and there we have the union. Okay, I hope that you've understood that. So please remember this formula, because it gives us the relationship between A or B and A and B. Okay, let us have a look at some examples. An exercise rather. So customers at a supermarket were asked if they bought milk and bread or both. 150 answered questions. So this is our total number of people. And it is 125 bought milk, 85 bought bread, and 70 bought both. So we have to fill in a Venn diagram. That's our first exercise. So we know our total sample is 150. So everything we add should add up to 150. We have people buying milk. We have people buying bread. Let's try that again. We have people buying bread, and there are people who buy bread and milk. Now, the ones that bought milk and bread, we don't know. We always start with filling in the innermost information. So we're going to fill in how many bought both. So 70 bought both. So you always start filling in the information from the intersections. Because this year didn't say milk only or bread only, they said bought milk. So we don't know what number belongs in this piece, which is the intersection, and what number belongs in this piece, which is milk only. But now, once we filled in the intersection, we can go back and then we can fill in the missing piece. So if 125 people bought bread, then if we would like to calculate how many people bought milk only, so 100 bought milk and 70 bought milk and bread. So to calculate how many bought milk only, we're going to say 125 minus the 70, which is 55. If we add them together, then we get the 125 that bought milk, and we know that 70 bought both, so that means 55 people only bought milk. Okay, and doing a similar thing, how do we calculate this part here, the people who only bought bread? We take the total number of people who bought bread and we minus the intersection, so there we get 15. So together, those numbers equal the 85 for bread and the 125 for milk. Okay, so that is our Venn diagram. And the first, then what we also have to do before we move on is fill in how many people did not have milk or bread. So they bought something else from the shop. And that's the people that are here. Okay, and how would we calculate that? We take the total number of people, which is the 150, and we minus everybody that's bought something, milk or bread. So remember, milk or bread are all of it's everything in those circles. So then if we calculate that, it's the 150 minus the 55 minus the 70 minus the 15. So 10 people did not buy milk or bread. Okay, so let us start the question. So it says, how many people bought neither? So we just calculated that it is 10. So 10 people. How did we calculate it? Well, there is the calculation up there. Another way of, so probability of neither, I think I spelled it wrong actually, is equal to 1 minus the probability of A or B. So the A or B, if you say 1 minus that, you get the probability of neither. But they ask you for the number of people, okay, not the probability in this case. Okay, so it says, what is the probability that a randomly chosen person bought milk only? So let's think about that. In our diagram, what is the one that represents milk only? So probability milk only. That is this piece over here. This piece over here is milk only. Because if we go to the other side, that's milk and bread. So that's milk only. So it's going to be 55 over the total, which is 150. So for the probability, it's the probability of that event over the total. Okay, the probability of bread only. So bread only, that is, again, we look at that piece. So it is 15 over 150. And then milk or bread, so the probability milk or bread, it's everything that's in these three circles. So we know it's going to be 55 plus 70 plus 15. Over the total 150, so it is 140 over 150. And that is the probability of people who had milk or bread. I hope that you have understood these two concepts of the union and the intersection. I hope that you've looked at this relationship over here. It's quite an important relationship. And finally, I hope that you've understood this example. I would like you to try as an exercise to calculate the probability of milk or bread using this formula. This formula, the probability of milk plus the probability of bread minus the intersection. And note, it's not milk only or bread only, it's the probability of milk. So this includes the and probability of bread minus the probability of milk and bread. Milk and bread. Okay, actually, let's do it together. If you pause the video, you can do it as an exercise and we can mark it. So the probability of milk, so the total number of people who bought milk is 125. So it's 125 over 150 plus the probability of bread. The total number of people who bought bread is 85. So it's 85 over 150 minus the intersection. So that's what's happening at the middle. So that's 70 over 150. And if we calculate this, we're going to end up with the 140 over 150, which is the same answer. So make sure that you know the different ways of calculating it, interpreting it, and good luck. Thank you for watching this video. Please subscribe and like, and I will see you with the next videos. Thank you. Bye.